Hi students, in this lecture I am going to discuss instantaneous axis of rotation. Let us see. So when we are taking a rolling motion, which is a combination of translation and rotation, that can be taken as a pure rotation about one axis, and that is known as instantaneous axis of rotation. I am repeating, we are knowing that rolling motion is a combination of translation of center of mass and rotation about center of mass. So this rolling motion can be taken as pure rotation about one axis, and that axis is known as instantaneous axis of rotation. Let us see carefully what is that. So when you are taking axis of rotation, the points on axis of rotation having zero velocity. Now coming to here, we are saying that this rotation plus translation, this is a combined one, is taken as a pure rotation about one axis. Okay, and that axis is known as instantaneous axis of rotation. And how to identify means we have to focus which point or which points having zero velocity, because when we are saying axis of rotation, all points on axis of rotation having zero velocity. For example, this is a body which is now rolling. It is rolling on ground. It is rolling on ground without slipping. In that case, for contact point, velocity is zero. That means about this contact point, we can take this motion, means rolling motion, as pure rotation. The contact point is having now zero velocity. So axis of rotation passing through this point. About this axis, this rolling motion can be taken as pure rotation with the same angular omega, means with the same angular speed. No change in that. Let us see. It is now VCM and omega, which is equal to VCM by R. Okay. For example, we want to calculate angular momentum of this body. Let us say about this line, means we can say about a point on this line. For example, this is a disk. This is now disk, which is now rolling without slipping. Let us take now this as x-axis. I am taking a point on x-axis. About that point, we are calculating angular momentum. So earlier we have taken angular momentum. Since it is rolling without slipping, we are taking angular momentum because of translation and because of rotation, right? And you can see because of translation, it is R bar cross P bar. Direction will be clockwise. Taking your right hand, curled fingers by keeping on R bar towards P bar. It is clockwise. And rotation also clockwise. That means now both are adding. So here, because of translation, M into V into R clockwise. Because of rotation, I omega, that is mr square by 2. Omega is now V by R, means VC by R. Now see what is the value. MVCR by 2. It is now 3 by 2 MVCR, right? Now we can take the same thing as pure rotation about this contact point. That means about this contact point with the same angular velocity. See how to write that? L bar about the point, take this point as P, about P. We are taking this as pure rotation about point P. See about this axis. If you take this board plane as XY plane and center of the disk as origin, axis is Z axis, right? It's virtual axis. This is now parallel to that axis. So about to P, I value mr square by 2 plus mr square, 3 by 2 mr square. So 3 by 2 mr square. That is I value about the axis passing through P into omega. On omega is now Vc by R. So we got same, right? So this translation plus rotation means a rolling motion can be taken as pure rotation about one axis. And if you see in this, this is a point P which is in contact at this time. The very next moment, the other point comes in contact with the ground. Means now that point, or you can say axis passing through that point is axis of rotation. And the very next moment, some other point comes in contact with the ground. That means here, the point which is in contact with the ground, axis passing through that point, and that axis keep on changing. That's why name is instantaneous axis of rotation. It is axis of rotation only at that instant. Okay, with the same angular speed. For example, we want to calculate kinetic energy of the body. See how we calculate kinetic energy of the body, total value, because of translation of mvc square. Because of rotation, half I omega square, I value mr square by 2. Because we are taking translation of center of mass, rotation about center of mass. That's why I value about center of mass. Half I omega square. Omega square is omega value Vc by R. This is now Vc square by R square. See what we get? R square cancelled. So I can take here half mvc square common, half half mvc square. Here 1, and it is now 1 by 2. It is now 3 by 2. That means the kinetic energy is now 3 by 4 mvc square. Now same thing we are taking about point P. It is in pure rotation. Then total kinetic energy equal to half I omega square. I value 3 by 2 mr square. Half I omega square. Omega square is now Vc square by R square. So both are same. So like this, when we want to calculate angular momentum, or if you want to calculate a kinetic energy, we can take directly about one axis, about which it can be taken as a pure rotation. Okay. So main thing we have to focus how to identify. The only key point is that any point on axis of rotation having zero velocity. So we have to focus which point is having zero velocity. So axis of rotation is passing through that point, right? Now let us take, if we are given velocities for 2 points in a rigid body, how to identify axis of rotation. Now see possibilities. For example, this is now a disk. In fact, we can take any shape. I'm taking here a disk. Let us take a disk. Consider 2 points in the disk. We can take any 2 points in the disk. Suppose I'm taking here one diameter and consider 2 points on that diameter. So I'm taking one point here. Let us call it as A. And this is one more point, take it as B. This is one more point, take it as C. Now you can see velocities for those points. Let us take omega is now anti-clockwise. It is anti-clockwise. Assume this is now in pure rotation. So I have taken one body here. It is a disk which is in pure rotation about its own axis. Let us take points A and B. For point A, because of rotation, velocity will be like this, direction part. For B also, direction same. The only change is magnitude of velocity. That means speed. Speed of A is less, speed of B is more. So we have learned that points which are closer to axis of rotation having less speed. So this has less speed, this has more speed. Suppose we are given now 2 points A and B, and for those 2 points, direction of velocity is same. So from this we can say that axis of rotation is closer to point A. It is outside these 2 points. It is not in between these 2 points. See carefully. When we are given 2 points A and B, for those 2 points, velocity directions are same. In that case, we can say that axis of rotation is outside these 2 points. Is it closer to A or closer to B? It is closer to A. It is closer to the point which has a less speed. Okay. So like this, we can guess it is outside these 2 points. For example, we are given 2 points A and C. We are given now 2 points A and C. Direction of velocity for A up, for C down. Now they are opposite. So from this we can say axis of rotation is in between those 2 points. That means basing on direction of velocity, we can decide is that a point is in between those 2 points or it is outside those 2 points. If both the points having same direction of velocity, then axis of rotation is outside those 2 points and closer to the point which has less speed. If we are given A and C, directions opposite, then axis of rotation will be in between those 2 points. And again, that is closer to the point which has less speed, right? Now, next possibility, direction of velocities, neither parallel nor anti-parallel. Let us take. Let us take 2 points. Suppose one point is here. Rotation is now like this. For this point, because of rotation velocity is along tangent, right? Velocity is always along the tangent because when body is in pure rotation, except the points on axis of rotation, remaining all points following circular path. Okay, I am taking one more point somewhere here. For this point velocity, it is again along the tangent, right? Now, if we draw normals for those velocity vectors, draw normals for these velocity vectors, then those normals will intersect. those normals will intersect at axis of rotation. Okay. So those normals are intersecting at axis of rotation. That means when we are given velocities neither parallel nor anti-parallel, then draw normals for those velocities. Okay. Point of intersection gives us axis of rotation, or you can say about which point body is in pure rotation. So we're having now here three possibilities. Velocity is either parallel, velocity is anti-parallel, or velocity is neither parallel nor anti-parallel. Okay, let us take one simple example to get more clarity. Right, let us take a simple problem. For example, take a rod. Take a rod. Its length, take it as a 4 meter. Its length is 4 meter. Suppose we are taking 2 points in the rod. Let us call it as A and B. Suppose the rod is now in the board plane, or you can take board plane is now horizontal. Rod is now in that horizontal plane. For A, suppose velocity is now 10 meter per second. And for B, velocity is 2 meter per second. Okay. So we are given a rigid body, and in that body, for 2 points, velocities are given, and separation between the 2 points also given. So just now we have discussed that if velocities are parallel, then axis of rotation will be outside the points. That means now we can see here, if you extend this line, if you extend this line, now this is axis of rotation. Suppose its distance from B is x. Okay, so which we want to calculate. That means you can take now, this is just like a rod of length OA. It is just like a rod of length OA, length equal to 4 plus x, whose one end is fixed. It is now rotating about one of its ends. The question is just like that. Okay. So now we want to find out distance of this point O. Then see what we are doing. So according to direction of velocity, we can say that this rotation is now clockwise, right? About this axis clockwise. So take it as it is omega clockwise like this. Then velocity 10 meter per second, that is equal to velocity 10 meter per second, that is equal to, right. See now what we can do here. We can write speed equal to r omega. Its distance from point O, x plus 4. So r is x plus 4 r omega. Now this is speed equal to again r omega. Here r equal to x, right? So point B is a following circular path of radius x. Point A is a following circular path of radius x plus 4. This is equal to x omega, right? Now see what we can do here. Take ratio 10 by 2 equal to 5. 10 by 2 equal to 5. That is equal to ratio omega gets cancelled. X plus 4 upon x. So 5x equal to x plus 4. That implies x equal to, it is 1 meter. Okay. So like this, directly we can get what is the location of instantaneous axis of rotation, right? Now do one thing. Let us take the same problem, but velocities are opposite. So it is A, velocity 10 meter per second, and for B, velocity 2 meter per second, only changes directions, remaining same. Separation between them 4 meter. Now in this case, axis of rotation will be in between the points, right? And as we have discussed earlier, it will be closer to the point which has less speed. Okay, it is closer to the point which has less speed. In fact, here, without writing this directly also, we can get omega value. See carefully, x got how much? 1. x1 means omega how much? From this we can write omega equal to how much? 2. So 2 radian per second, right? And in the beginning of the chapter, we have discussed how to calculate angular velocity for a rigid body, right? One is if we are knowing theta as a function of time, then writing d theta by dt. Second one is if we are given velocities for 2 points in the body, then finding relative velocity normal to the line joining them, then divide with separation between them. We can see here normal to line joining them, relative velocity. It will be 10 minus 2, that is 8. Dividing with separation, that is a 4. 8 by 4, that is 2. That is what we got here, right? Directly we can do like that. And once it is known, 2 equal to x into omega. Omega is 2. So x value 1. So we can solve in that way also. Okay. Now coming to here. Since directions are opposite, since directions are opposite, axis of rotation will be in between these 2 points. It is somewhere here. Suppose that separation from B is equal to x. Okay. So now see how to find. We can write 2 meter per second is equal to x omega. So we can find omega directly by using relative velocity, then separation between them, right? See relative velocity 10 and this is 2. Directions opposite. So relative velocity is 12 meter per second. Separation is now 4. 12 by 4, it is 3. So omega value, it is 3 radian per second. Okay. Now substitute that value here. X will be 2 upon 3 meter. Okay. Means either we can solve by using in this field. So writing here 10 equal to how much? 4 minus 6 into omega. 4 minus 6 into omega. 2 equal to x into omega. Then simplifying those two, we get x value. Then we get omega value. So here what I have done, first I made calculation for omega, then for x. Okay. So we can do in either way, right? Let us see now last possibility, that is velocity is neither parallel nor anti-parallel. See once, see the question here. At some instant, a particle is moving along a straight line, along a straight line 2x minus 3y equal to 2, and its coordinates on that line are 4, 2. Now, at Other instant, same particle is moving along a straight line 3x plus 4y equal to 7 and its coordinates are 1, comma 1. Find the coordinates of that axis about which it is in pure rotation. So we are given now two straight lines and a corresponding point. Okay. Now see how to solve it. Right. First of all, write down the given data. So given that 2x minus 3y equal to 2 and its coordinates are 4, comma 2. And same particle at some other instant, it is along the line 3x plus 4y, that is equal to 7 and coordinates are 1, comma 1. So first understand meaning of this. Suppose I am taking here a disk. Okay. Now we are focusing one point on the disk. One point. Take one point on the disk. Okay. Now let us say omega clockwise. At this instant, its velocity will be along the tangent like this. So I can imagine one line which is passing through that point, right? That is now this line equation. And this point can be anywhere on that line. So that's why they're specifying what is location of the point. It is a 4, comma 2. After some time, this will be somewhere here, right? Again, its velocity will be along the tangent. Again, you can imagine here one straight line. That is now this equation. And where is this point on the straight line? It can be anywhere, right? On that line. That's why we are given location of the particle 1, comma 1. So I hope you are getting meaning of the straight line equations and corresponding points. This is at one instant, one point. Velocity along this direction. So imagine one line. That is line equation. Where is a particle? It is at this point. For this point coordinates. Now same point after some time, it has velocity in this direction. Means along this line. So this is the line equation. At this point, that is coordinates of that point. So if we draw normals for those lines, normals, point of intersection gives us, it is axis of rotation. So I hope you are getting it. So once it is clear, the remaining is just a calculation part. In fact, we can do this of your own. Given line equation, for this line, we have to get a normal. Then see what we are doing here. For this normal is, I am taking 3x plus 2y is equal to some constant, right? Taking some constant here and its value, its value, substitute now this point here because this normal is a passing through that point, right? Same point. So I'm taking here 4, 3 4 so 12 and 2 here, 2 2 so 4, 12 plus 4, 16. So this must be 16, right? Next, coming to for this one, normal, it is 4x, 4x minus 3y. That is equal to, again, this normal is a passing through same point. That's why again 1, comma 1. Take here 1, 4. Again 1 here, 3. 4 minus 3, it is 1. So we got now two line equations. We have to find now point of intersection for these two lines, right? And if you simplify this, we are going to get x and y, right? So x value 50 by 17 and y value it is 61 by 17. So I think you can make calculation for this. Suppose if you want to eliminate x, then say what you have to do? Multiply first equation with 4, second equation with 3. Then say what we get? 4, 12x plus 4, sorry, 4 plus 8. 8y, 8y equal to 64, right? Next, multiply now this with 3. 12x minus 9y equal to 3. Now subtract from first, subtract the second one, 12x minus 12x 0, 8 minus 9, 17y. That is equal to 61 minus, sorry, 64 minus 3, 61. So y is 61 by 17. Then we can find the x coordinate. Okay. So like this, we can get location of instantaneous axis of rotation. Okay. So I hope you got the clarity. So answer is now, it is option B, right? 50 by 17, 61 by 17, right?